So the lesson intention we have today is to identify the various different types of chemical reactions, and we want to explain their differences based on the way each substance is arranged when the reaction occurs. So the first one we're going to look at is called synthesis reaction. If you can have a look at this animation here, you can see a synthesis reaction is when two or more types of molecules or chemicals combine together to form one larger one. Effectively, another way of calling this is a combination reaction. And a synthesis reaction occurs when two or more reactants combine to form one single product. A synthesis reaction is an example of exothermic, or an example of an exothermic reaction. What that essentially means is an exit of heat. So if you experience a chemical reaction that is exothermic, when the reaction has occurred, you'll feel that the surrounding vessel of where the reaction is will get warmer. The general formula to represent a synthesis reaction can be labeled like so: A, B as any random reactants combine to make C. So some examples where you can see this is nitrogen monoxide plus oxygen to make nitrogen dioxide. Another famous one would be sodium plus chlorine, and in this case chlorine gas, to make sodium chloride. Now if you remember what sodium chloride is, the common name is table salt. And it's a very important spice that we use for cooking, but it's actually made from a highly reactive metal and a highly toxic non-metal. But when combined together, it is a very stable, very flavorful seasoning. There's a nice little video out there that you can watch in terms of demonstrating the synthesis of oxygen and nitrogen. I'll put a link below and you can have a look at that. The next one we have is combustion. Now combustion is sort of an example of combination as well, but specifically we're looking at the combination of a metal or non-metal to oxygen. So when it comes to combustion, we're talking about how things combine to oxygen. This is a nice little example. It's called the ethanol bottle. So if you have a bit of alcohol surrounding the rims of the bottle, you can actually have this really nice effect. There's also a thing called the ethanol rocket that I might even try and show later on. So a combustion reaction occurs when a compound or an element, usually containing one carbon or metal, combines with oxygen gas in the air. So the general formula for combustion is shown here. The reason why we have the question marks is obviously it can be a hydrocarbon compound, or a metal, so that's why we leave it blank. But in general, you can find two main categories for combustion. The first one is combustion of hydrocarbons. Hydrocarbons is any chemical that's made of a certain amount of carbon with a certain amount of hydrogen. Now fossil fuels are examples of hydrocarbons, and when you burn fossil fuels like methane, you produce carbon dioxide and water. So obviously that's why the combustion of fossil fuels is quite not a desirable outcome, because it leads to an increase in the CO2 concentration. Another example where combustion occurs is the combustion of metal. So here we have magnesium, combustion with oxygen, and you get magnesium oxide. So sort of a thing that you might see after this reaction is the metal becomes dull. what's actually happened is metals have lost its lustrousness. Basically, another way of saying its shininess. So if the metal has lost its shininess, it could be because of addition of oxygen onto the top layer. The next example we're going to look at, or the next type of reaction we're going to look at, is called a decomposition reaction. So what you can see here is you have one large molecule compound and it breaks into smaller components. That's the idea of what a decomposition reaction is. This is a famous example. This is mercury oxide. When mercury oxide is exposed to heat, it will go through what we call a thermodecomposition, and it breaks into mercury and water, or mercury and oxygen, sorry. Okay, so there's that. A decomposition reaction is endothermic. Now, what does that mean? So if something is endothermic, it means the heat is taken away. Okay, so heat is taken into the reaction. So in the form of an endothermic reaction, you should find that the surroundings get colder. Unlike exothermic, where we expect an increase in temperature, endothermic reactions we should expect a decrease in temperature, because what's actually happening is energy is being absorbed by the reaction to allow for this reaction to occur. So, example here, we actually need energy to go in to break the bonds between A and B and separate it into two components there. This is our general formula to describe a decomposition reaction. This is just one of the examples. So if we want to decompose water into hydrogen and oxygen, this is what we're seeing here. Okay, this example is known as electrolysis. So it's actually using electricity to separate water into hydrogen and oxygen, because water is a very stable compound. So it needs a little bit of a kickstart to cause this breakage. The next one we have is known as a single displacement reaction. So in a single displacement reaction, we should see one atom coming into the compound while another atom or element leaves the compound structure. So in this case we have iron entering copper and sulfate, so that's what we see here. And the sulfur, or the copper, is the one that disappears. Okay? With this example that we have here, I do believe we have the copper in zinc potentially, so that's the formation of copper displacing the zinc. So a single displacement reaction occurs when a more reactive element displaces or swaps, if you like to use, swaps places with a less reactive element compound. This is the general formula to describe a single displacement reaction. An example of a single displacement or substitution reaction is when we have a piece of metal reacting with acid. So what happens here is the metal displaces the hydrogen. The hydrogen will form to make hydrogen gas. It will displace the hydrogen and form a bond with the chlorine. Okay, so that's an example. An acid plus metal reaction. And so another one we can talk about is a double displacement reaction. This is known as the golden rain reaction, and it's formed by lead iodide. So with a double displacement reaction, we see we see a complete swap of two combinations of compounds. Okay, so as you can see here, the swap over that's happening is with this white sphere and this dark sphere swapping, and these two forming to each other. So that's what we mean by a double displacement. We have a two-way exchange going on. Okay, so a chemical reaction with two compounds react. The positive and negative ions essentially swap places with each other. Now, the best example of a double displacement reaction is a precipitation or a neutralization. This is the general formula to describe a double displacement reaction. You can see the major thing that we see here is that A element has swapped over to D, to bond with D. This C element has swapped over to bond with B. Okay, so we have a direct swap over of both compounds. Alright, so precipitation. This is an example of precipitation. When you have two liquids, so that's where the aqueous comes from, combine together and a solid is formed. There's two ways of knowing if you formed a precipitate. One way is formation of solid. Another way is formation of color. So when these two come together, you know a precipitation reaction has occurred. Now, not all compounds mixed together will cause a precipitation reaction, only specific combinations. We will look into a bit more about precipitations later on in this series of lessons. Okay, so we have our lead iodide there. Another example is neutralization. So neutralization is when you have an acid reacting with a base. Again, we'll look into a bit more detail what an acid and a base is. It forms a salt. Now, salt in the form of chemistry just means metal plus non-metal. And water. Okay, so you can see in this case here, a salt is a combination of a metal and non-metal. Using our example that we have with this equation, we have hydrochloric acid and sodium hydroxide. If you use your periodic table, you can actually work out which one is the salt. Now, sodium is a metal. Look at the acid, which is the non-metal component. Okay, the non-metal component, assuming because this hydrogen is going to react to make water, we can discount that. This sodium is going to react with this chlorine. This hydrogen is going to react with this hydroxide group. And so you can see there's a double displacement occurring. There's two exchanges going in this reaction. Neutralization is an example of an exothermic reaction. So if you mix an acid with a base, you should feel a increase in the heat of the reaction. Alright, so an example of neutralization, as you can see, is here. The swap, and you can see the double displacement with the acid and the base. Alright, so that concludes what we need to talk about for this lesson. What I want you to do is just do a real quick checkup of your understanding. So these are some general equations of these particular reactions. What I want you to do is label the relevant reaction with the relevant general equation like so. Anyhow, thank you for joining, and hopefully you've been enjoying this series related to chemistry. There are some other nice videos that you can look at in the playlist. And also, if you want to look at some nice experiments related to chemistry, there is also some videos on that as well. Alright, so until next time, please take care and hope you enjoyed the video.